Okay, so today I want to show you how I made this display, which is a recreation of that display from Teenage Engineering EP133 Knockout 2 sampler. Yeah, that's a long name. And this display has quite interesting and unusual shapes. Each digit is made from 10 segments, and obviously this is a custom-made segmented display, but recently I was experimenting with segmented displays made on breadboard using a custom 3D printed diffuser, and I have this video with a simple 7-segment design, as well as this video with slightly more advanced design, so I thought let's continue with this series and create another segmented display. However, this time it will be slightly different. I'm not using NeoPixel LEDs like I previously did, but a very common 8x8 LED matrix display. The secret sauce is of course this 3D printed part, and that one makes sure that the light from those LEDs ends up in the corresponding segments. So it's directing the light to those segments, and that's pretty much the whole secret. So let's get started. Actually, before we start, let's talk about the sponsor of today's video, which is PCBWay. And that's because if you are making projects like this, sooner or later you might need custom PCB or PCB assembly or SMD stencils, and in all those cases, PCBWay has you covered. They offer all of those services for a reasonable price. On top of that, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. And if you need anything else for your project like 3D printing or CNC machining or even injection molding, PCBWay offers all of those services. So thank you PCBWay, and let's get back to our project. Now the idea of using the 8x8 LED matrix display to create a segmented display is not mine. I have seen it in a video from the user Shiura, that's this video. Here a 3D printed part is used to convert the 8x8 LED matrix display to 16 segment display, actually 4 of them, because 8x8 has 64 LEDs, and 16 segment display obviously needs 16 segments, so you can fit 4 of them because 4 times 16 is of course 64. And since my display has only 10 segments, in theory I can fit 6 of those displays on one LED matrix display, but because this is quite so small, I decided to only place one display to make it simple, which means that some of those LEDs are actually not used. Going back to the Teenage Engineering display, again, those displays has quite unusual shapes, but I have seen those shapes before on this old electroluminescent segmented display. Here is a video from Kainka Labs which shows those EL displays. This display has 8 segments, the one from Teenage Engineering has 10 segments, so 2 more segments were added in the middle to allow for more characters to be displayed, but you can clearly see the inspiration for that display. Also, Teenage Engineering has another version of this sampler called Medieval, where the segments have slightly different look to match the theme. Okay, so with all that said, let's finally get back to our project. We will be using the Arduino UNO with the 8x8 LED matrix display, not just the display but the display module that uses the MAX7219 chip to drive those LEDs, that's this chip. And the good news is that I already have some videos describing how to use that display. I have used those displays inside a custom-made wooden clock. I also have this video where I show how to use those displays with the U8G2 library. I was also experimenting with some overlays to change the shape of those pixels, those are SMD stencils. And one unusual way how to use that board with the MAX7219 chip was to not drive the 8x8 LED matrix display, but the ring light instead. So this is the ring light around the potentiometer being driven by the MAX7219 chip, and I had to create a custom PCB for that. And then I have decided to create a custom PCB with those LEDs, which looks something like this. And I will start with this project because there should be a link to the Wokwi simulation. Now Wokwi is a free online Arduino emulator running in the browser. And this is a very simple sketch using the components that we will be using, the Arduino UNO connected to the 8x8 LED matrix display. So as I'm rotating the potentiometer, I'm slowly filling up the display. And this sketch uses the LED control library. So first we need to define the connection for those pins, so the clock pin, the chip select pin and the data in pin. Those are connected to pins 10, 11 and 13, but I believe that any pins could be used on the Arduino UNO, I mean any digital pins. And then of course the ground pin is being connected to ground, and then the V+ or VCC pin is being connected to 5 volts. In the setup function there is some initialization to start up the chip and then set the intensity, set the brightness and clear the display. And the first parameter, the number 0, is the index of the display, because we can chain multiple displays together, and that's actually in here, so we are setting that we have only one display. I believe that the brightness, the intensity goes between 0 and 15, so 8 is somewhere in the middle. And then inside the main loop, we are reading the value of the potentiometer, and based on the value, we are either setting the LED to be shining or not shining. So again, the 0 is the index of the display, then there is the X and Y position, the row and the column, and the last parameter is setting if the LED should be shining or should not be shining. Now, instead of setting those individual LEDs one by one, I would like to draw the image. And I have found this online editor called the LED Matrix Editor, where we can actually draw images just by clicking on those LEDs. And if I scroll down, there is even the Arduino example, which uses the very same LED control library. So let's just copy this Arduino code, and I will paste it into our Arduino sketch inside Wokwi. But before I do that, I will delete all those comments, and I will actually keep this line of code in here because there is this connection, the current connection, and that might be different from the connection from that Arduino code. And that's actually the case because our data in pin is set to pin number 11, but in this code it's set to pin number 7, so let's just change it to pin number 11. Then the clock pin should be 13, so instead of setting clock pin to pin number 5, let's just change it to pin number 13. And finally the chip select pin should be the pin number 10, so the chip select pin should be pin number 10. And then we can delete our old code, and I guess I can stop the simulation and also delete the potentiometer because we don't need it anymore, and then restart the simulation. And once we do that, we see some kind of animation, which I guess is being stored in this variable in this array. So we should be able to go back into the LED matrix editor and draw our own image, and we can then use this variable, those data, to draw our own images. The problem is that at this point we don't know which LEDs we want to light up. So as a first step, let's draw the shape of the Teenage Engineering 10-segment display over the 8x8 LED matrix display. And to make things easier, I mean easier for me, I'm using Adobe Illustrator, but you can use any tool you want, any tool you know how to use, and it could as well be just pen and paper. So what I'm trying to do in here is to draw some rough shape of this 10-segment design over this 8x8 LED matrix display. And again, I'm not looking for the final design, but I want to understand which LEDs will be covered by which segment, and which LEDs might not be used at all. So let me just speed up this process a little bit. In the end, something like this might work. So it's time to identify which LEDs are occupied by which segments. And I've recolored those segments with different colors. And then I've also colored those underlying LEDs. And I think everything looks fine with two exceptions. The first exception are those four corners, because those LEDs are being occupied by two segments, actually just a tiny portion of this segment. So I think that what we can do once we print the 3D diffuser is to just change the shape slightly to not include this part of the LED. And the second problem are those middle pieces which are not perfectly aligned with any of those LEDs. But thankfully, since we can use 4 of those LEDs for those segments, I'm hoping that enough light will be able to get into those segments to make them bright enough. So that's the plan. Let's start by lighting up those individual LEDs on the LED matrix display. And again, let's use this LED matrix editor. I will draw the number 0. Then we need to click the update button to update the actual data, and then click the insert button to insert another image, and we can quickly delete the content by clicking this icon to just turn everything on and everything off, and continue like this with all the other digits. With 10 segments, there are usually multiple ways how to show the same digit, but I'm trying to use the very same layout as on the Teenage Engineering display. So once we have all the digits, I will copy the code into the clipboard, only just the data for those digits, and then jump back into the Wokwi sketch and paste the data in here for the images. And I don't think that we need to do anything else because the number of images is being calculated using this line. So let's just try to restart the simulation to see what happens. And we see those individual digits, but they are changing way too fast. So let's just increase the number in the delay function from 100 milliseconds to maybe 500 milliseconds, which is half the second for each digit, and restart the simulation one more time. And this looks fine, so let's try to run it on the real Arduino board. For that, copy the code into the clipboard, then open the Arduino IDE and paste the code in here. And just because we are using the LED control library, we need to make sure that this library is being installed by going into libraries. And then of course searching for the LED control. And if you don't have this library installed already, you need to click the install button to install the library. Then we need to connect the Arduino UNO board to the PC using the USB cable and select the Arduino UNO from the drop-down menu. And then just click the upload button. And it should be very quick because the sketch is very small. And of course on the Arduino we don't see anything because we don't have the 8x8 LED matrix display module connected yet. To connect the Arduino UNO to the display, we should use the very same connection as inside the Wokwi sketch. The DIN pin, the data in pin, should be connected to pin number 11, the CS pin, the chip select pin, should be connected to pin number 10, the CLK pin, the clock pin, should be connected to pin number 13, and then the ground should be connected to ground and the VCC to 5 volts on the Arduino board. And once we have it connected like that, we should see those individual digits lighting up on the LED display. And even now, those looks like proper numbers, proper digits, but I'm sure they will look even better with the 3D printed overlay. So let's create that 3D model, and for that we will be using the Autodesk Fusion. And if that's your first time using this application, I do have a few videos which covers the very basics of using this application. As usual, I will put the links to those videos down in the description. Inside the Fusion, we want to create a new sketch by clicking the Create Sketch button and then clicking the floor plane. And before we draw those segments, let's start by drawing the 8x8 LED matrix display. I have this not so great looking blurry image, but it shows all the important dimensions. So the size of the LED is 3mm with the 4mm spacing. Let's draw just one LED with the circle tool, so select the circle tool and set the radius to be 3mm. And maybe move it more towards the center and then zoom in a little bit more. And we want to set the X and Y position of this circle by setting a new dimensions. So select the Sketch Dimensions tool, then click the center of the circle and then the circle of the sketch. And set the X position, and for now let's set it to 4 × 4mm, which might or might not be correct dimension, but we can always change it later. And then do the same thing for the Y position, so click the center of the circle and center of the sketch and set it also to 4 × 4mm. We want to duplicate this circle multiple times to have 8 rows and 8 columns, and for that we will use the rectangular pattern tool, so just select that tool and then click the circle. And then move this arrow to the right side and move this arrow to the bottom side. And we want to have 8 columns and 8 rows. And looking at our blurry image, the spacing should be 4mm × 7 for both the X and Y position, so 4 × 7. Actually for the Y position it should go downwards, so it should be -4mm × 7. And then click the OK button. And you can see that the X and Y spacing is not correct because the center should be in here, so offset by half of the spacing. Which means that the X position shouldn't be 4 × 4mm but only 3.5 × 4mm, and the same spacing should be also for the Y position, so 3.5 × 4mm, and that should put all those LEDs into the center. Let's also visualize the outside by creating a new rectangle, and that will be this one, the center rectangle, and draw it from the center of the sketch, and the size should be 32 × 32mm. Let me just quickly move those dimensions around to be more readable, and our 8x8 LED matrix display sketch is finished, so click the Finish Sketch, and then just rename it to be 8x8 LED matrix display, and we can move on to create those individual segments. Since I already have the sketch from the Adobe Illustrator, I will put it on the side and use it as a guidance. And in the Fusion, I will quickly hide this sketch and create a new one by clicking the Create Sketch button, and again create a new one on the floor plane. Then we can show the 8x8 LED matrix display and start drawing those segments. And since those segments are symmetrical in both the X and the Y orientation, I guess what we can do is we can just draw this section of the display and then mirror it on the X and Y planes. So as a very first step, let's draw a new rectangle, this one, the 2-point rectangle, and draw it from the center to the left and top, and set the size to be 16 by 16 millimeters. And then select the line tool, and let's start by drawing the first segment, actually part of the segment. And I will start with the one on the very left side, so starting on the bottom, touching the rectangle, so it snaps to the rectangle, then going up and making sure that this is the horizontal line, actually vertical line, then going to the right side and back to the bottom to touch the rectangle. Now since all those lines are blue, it means they are not constrained, so we can move them around. So let's just add a few dimensions by clicking the Sketch Dimensions tool, and let's just say that the width of the segment should be the same as the size of those LED, which is 3 millimeters. And let's align this segment to be exactly over those LEDs by setting the dimension between this line and that should be 8.5 millimeters. Which means that now we cannot move those lines left and right, but we can still move this line, but that's probably fine for now, we will fix it later. Let's move on to the next segment, and again let's use the line tool to draw this segment. And let's start around here, then go down and closer to the center, but it shouldn't be touching the center, there should be a small gap, like so. Then going back, going up, and closing the segment with those two lines. Let's adjust the segment to look more refined, starting with the Sketch Dimensions tool and setting these dimensions to be again 3 millimeters. And then also this dimension should be 3 millimeters. The gap between those individual LEDs is 1 millimeter, and we can easily measure it by going to Inspect, Measure, and then measuring this distance, which is 1 millimeter. So let's use the very same gap size in here, but also down here. However, down here this gap will be mirrored, so it should be only half the size, so instead of 1 millimeter, this will be only half the millimeter. So let's select the Sketch Dimensions tool and set this distance to be again only 0.5 millimeters, as well as this distance between this line and the bottom line again to be only 0.5 millimeters. And then let's set this gap size to be 1 millimeter. Now it would probably look nice if this line would be like a continuation of that line, and there is a constraint for that called the collinear constraint, so we can use the collinear constraint between this line and that line, and now those two lines act like they are connected with, of course, this gap in the middle. Now we have a lot of blue lines, meaning they are not constrained yet, but let's ignore those for now and continue with another segment. And let's draw the middle one, which should look like this, but again we are only drawing 1/2 of the segment. So again let's select the line tool and draw it from the center, going to the left, going to the bottom, and then go back into the center. And the size of the segment should be 3 millimeters divided by 2, which is 1.5 millimeters. And let's also visually align it with this LED, so this dimension should be 11.5 millimeters. Also having those two lines in different angles doesn't look very nice, so let's just fix it by using this parallel constraint, so parallel between this line and that line. And then the gap size between this and that line should be again 1 millimeter. There is only one segment missing, and that one should look like this. So for the last time, let's select the line tool and go from here to around this shape. Then set the size of the segment to be 3 millimeters. And align it to the LED, which is almost correct, 15.5. Then set those two lines to be parallel, and if we select both lines, we can just click the parallel constraint and it will add the constraint. The gap size should be 1 millimeter. And let's align all those three lines by applying the very same constraint, which is this one, the collinear constraint between that line and also that line. And then we can either move those blue lines or perhaps change this angle by setting again the sketch dimensions and maybe set this to be 45 degrees only to just rotate it slightly and move this down and maybe this to the left side. And finally, let's move this line to not go over that LED. And again, since this position is not constrained, we can just move this around like so. And maybe if we rotate this line a little bit, it will not go over that LED. However, if we select the Sketch Dimensions tool and try to set this angle, you will see there is a problem because there is already some constraint setting this angle. So let's just take a closer look, and I think that somewhere in here there is this perpendicular constraint, which might be in here, which is not the case, but there is one in here. So let's just select the perpendicular constraint and delete that one. So now we should be able to sketch a new dimensions being the angle of that line, and instead of using 135, let's go with something like maybe 120. That might be too much, so maybe 125, that should still be fine. And looking at those shapes of our segments, I think that maybe this angle could be the same as that angle. And I don't think that this angle is actually set, so what we can do is we can use this parallel constraint, so parallel between this line and that line. And there was almost no change because it was very similar angle. If we want, we can also move this line more to the bottom, so there is a smaller gap between this LED and this segment, but I don't think it will make any big difference, so I can just keep it that way like so, and maybe move this one around a little bit like so. So even when in my original design some LEDs were shared with multiple segments, that's actually not the case in here, because each LED is only for one segment, which will of course make things much easier. Now if we want to see the design better, we can hide the dimensions and the constraints, and maybe even the 8x8 LED matrix display sketch. And let's actually finish the sketch and extrude this piece by using the extrude tool and extrude this piece by, for example, 15 mm. And now it has some depth and we can mirror it using the create mirror tool. And we want to mirror this piece and select the plane which will be this plane. The operation should be set to join, and let's do it one more time. Create mirror and mirror this piece and set the plane to be that plane. Again, set the join operation and click the OK button. And now if we view it from the top, we can see those individual segments. And yes, it looks slightly different from the Teenage Engineering design, but it's nicely aligned with the 8x8 LED matrix display. I mean, yeah, except for those middle pieces, but I'm hoping that 4 LEDs will be able to provide enough light for this small segment. Before we 3D print this piece, this area and this area is very thin, so let's just expand this shape a little bit. For example, by going into the 8x8 LED matrix display sketch, and let's use the offset tool to offset this shape by, for example, I don't know, maybe like 2 mm. Then click the finish sketch button and use the extrude tool to extrude this area by the same amount of being 15 mm. And maybe round those edges a little bit by using the fillet tool of those 4 edges, and let's go with 2 mm as well. So I think that now we can 3D print this shape. We just need to select File, 3D Print, select the application, and since I'm using the Bamboo Lab 3D printer, I will select the Bamboo Studio and click the OK button, and that should start the Bamboo Studio application. And open that file, and let's just print it in a black color for now, the black PLA matte material. I'm using the Bamboo Lab X1 Carbon 3D printer with the 0.4 mm nozzle. So let's just click the slice plate button and everything looks fine, there are no surprises. So let's just click the print plate button to send it to the printer and print it. It will take about 30 minutes and here's the short time lapse right from the printer. Here is the finished 3D printed piece, and if we put it over the 8x8 LED matrix display, we are redirecting the lights from those LEDs into those individual segments. However, to make it look like a real display, we need some diffuse layer, and while we can use a piece of paper, a better way might be to 3D print the last layer in the white PLA material. That filament is slightly translucent, so if we only print one layer, it should be transparent enough to act like a diffuser. By the way, the reason why we don't print everything in the white PLA material is exactly the same. The walls between those segments are quite thin, so some light might be bleeding between those segments if we use the white PLA. You can see that with the white 3D print, even the segments which shouldn't be lit are slightly shining. So let's use black PLA for the 3D print and add one more layer in the white PLA, and for that we need to go back into the Fusion. In here, let's create a new sketch here on the top or on the bottom of the 3D shape. And since we wanted the diffuse layer to be the first one being printed, let's add a new sketch on the bottom of the 3D shape by clicking the new sketch button or create sketch button and then clicking on the bottom. And let's project this 3D shape onto our 2D sketch by going to create, project include, click the project and then click the 3D shape. Click the OK button, and if we hide the 3D body, we now have the content of the 3D shape onto our 2D shape. So we can just finish the sketch and then select the extrude command and extrude everything by one layer, which in our case is 0.2 mm. But before we click the OK button, let's also show the 3D body, the rest of the 3D body. And if we do that, it should change the operation to join, so it will join this diffuser layer with the main 3D object. So click the OK button, and we now have the 3D body where the first layer is actually flat, that's the diffuse layer. If we want, we can show the cross section by going into Inspect, Section Analysis, and then selecting this plane, maybe just hide the body and select that plane. OK, and then show the body, and we should clearly see the bottom diffuse layer. So with this new updated 3D body, let's 3D print it again by going into File, 3D Print. Of course, selecting our body and then clicking the OK button. That will start the Bamboo Studio application. And in here we want to print it using two different filaments. The very bottom layer should be white and everything else should be black. And I've already loaded those filaments into the AMS unit, the Automatic Material Selection unit, for the Bamboo Lab X1 Carbon 3D printer. I have this white PLA matte and the black PLA matte materials that I want to use for printing. And you can see that currently I only have this black PLA matte material set, so I need to click the plus icon to add the second one, which will be the white one. And then we want to recolor section of the print, and for that we can use this function which is called the color painting. And we want to paint with the white color on those individual layers, so we will select the height range option and set the height to be 0.2 mm, which is the height of one layer. Then we want to zoom in as much as we can so we can see those individual layers, and click on the very first layer like so, like this, and that should recolor it with white color. And that's all that we need to do, so we can click the Slice Plate button and that will slice it, and by default we don't see any colors, so we need to switch the color scheme to be the filament colors. And in here we should see that everything is black except for the very first layer, which is white. And since it looks fine, let's 3D print it using the Print Plate button. To send it to the 3D printer it will take about 37 minutes, so just click the Send button and wait 37 minutes. Again, here is a short time-lapse right from the 3D printer. And here is a finished 3D printed piece. And if we put it on the LED matrix display, we have a very similar segmented display as the Teenage Engineering display. I'm using this blue LED matrix display because it's nicely visible on the camera, but you can also get it in a few different colors like the red, white or green. In one of my videos I was using the display which didn't have the round LEDs but they were square instead, but somehow this kind of display is very hard to get. Anyway, that's all for today. As usual, all the source files are on GitHub, the link is in the description. If you have any comments or questions, please put them down in the comment section. Thank you very much for watching and I hope to see you soon. Thanks and bye.